The silence of the late Cretaceous plains is absolute, broken only by the rhythmic drumming of dozens of slender feet. High in the sky, over the ancient Nemegt of Mongolia, the sun beats down on a land defined by vast river systems and shifting floodplains. Suddenly, a flash of movement erupts from the tall ferns as a group of elegant, bird-like silhouettes streaks across the landscape. They move with a fluid and terrifying speed that makes them seem like ghosts in the tall grass. This is Gallimimus boletus, the chicken mimic. Despite its deceptive name, it was a giant of its lineage, a 6-meter-long sprinter that traded the heavy armor and massive teeth of its contemporaries for the pure and unadulterated power of velocity. In the grand theater of prehistory, it remains the ultimate evidence that survival in the age of tyrants was often a matter of being the fastest thing on 2 legs. The scientific journey of Gallimimus began in the early 1960s, a period that marked a significant chapter in the history of Central Asian paleontology. During a series of legendary Polish-Mongolian expeditions into the Gobi Desert, researchers led by the pioneering Zofia Kielin-Jaworowska uncovered a wealth of spectacular fossils in the Nemegt Formation. This geological layer, dating to approximately 70 million years ago, represents one of the most productive dinosaur graveyards in the world. In 1963, the team discovered the first remains of what would become the type specimen of Gallimimus boletus. The discovery was revolutionary because it provided a nearly complete look at a group of dinosaurs known as the ornithomimids, which were previously known from much more fragmentary remains in North America. The formal description of Gallimimus was published in 1972 by Halska Osmolska, Ewa Roniewicz, and Rinchen Barsbold. The name Gallimimus, meaning chicken mimic, was chosen to reflect the striking anatomical similarities between the dinosaur and modern galliform birds, although Gallimimus was significantly larger than any chicken to ever walk the earth. The species name, boletus, refers to a bulla, which is a rounded and bubble-like structure found at the base of its brain case. These initial discoveries included individuals of various ages, ranging from juveniles to fully grown adults. This spectrum of fossils allowed paleontologists to study the growth patterns and ontogeny of the species, revealing how these animals transitioned from small and nimble hatchlings into the 6-meter-long giants of the Nemegt River valleys. To understand the ecological success of Gallimimus, one must analyze the specialized engineering of its skeletal frame. Gallimimus was a masterpiece of cursorial evolution, featuring a body plan optimized for high-speed locomotion. An adult reached lengths of up to 6 meters and weighed approximately 400 to 500 kilograms. Its entire anatomy was a study in weight reduction and aerodynamic efficiency. The skeleton was filled with pneumatic chambers, which means the bones were hollow and light, much like those of modern birds. This allowed the animal to maintain a massive size without the cumbersome weight that plagued other herbivorous dinosaurs. The hind limbs of Gallimimus were its most formidable asset. The proportions of the leg bones are a classic indicator of a high-speed runner, where the lower leg and the feet are significantly longer than the upper thigh bone. Specifically, the metatarsals were elongated and tightly fused, providing a stable and spring-like platform for explosive acceleration. Mathematical models and biomechanical studies suggest that Gallimimus could reach speeds of up to 50 or 60 kilometers per hour. When moving at these velocities, the dinosaur carried its body horizontally, with its long and stiffened tail acting as a dynamic stabilizer and counterweight. This tail prevented the animal from toppling forward during sharp turns and allowed it to maintain its center of gravity over its hips, which was a necessity for an animal that relied on agility to navigate the dense river galleries and uneven floodplains of its home. The skull of Gallimimus was unlike that of almost any other dinosaur of its time. It was small, light, and perched atop a long and flexible S-shaped neck. One of its most striking features was the complete absence of teeth. Instead of a traditional mouthful of serrated blades, Gallimimus possessed a toothless and keratinous beak that resembled those of modern ostriches or ducks. For many years, the dietary habits of Gallimimus were the subject of intense scientific debate. Some early theories suggested that it might have been an egg thief, while others proposed that it used its beak to filter small organisms from the water, much like a modern flamingo. However, detailed examinations of the beak structure in the late 20th century revealed a more complex reality. The edges of the beak featured fine and comb-like structures that could have been used for straining plants or capturing small invertebrates. Modern consensus suggests that Gallimimus was likely an omnivore, or a generalist herbivore. Its long neck allowed it to reach high into the trees for foliage or dip down into the water to forage for aquatic plants and small crustaceans. The large orbital openings in the skull indicate that it possessed exceptional vision, which was critical for a social animal that needed to track the movement of its herd and stay vigilant for the approach of predators in the low light of the forest understory. The discovery of multiple Gallimimus individuals in close proximity has led paleontologists to conclude that these animals were highly gregarious. Living in a herd was a vital survival strategy in the Nemegt Formation, an environment where the threat of predation was ever present. A group of dozens of individuals could share the burden of vigilance, with multiple sets of eyes scanning the horizon for the slightest movement. This collective awareness made it nearly impossible for a predator to approach the group undetected. The social structure of Gallimimus likely mirrored that of modern ratites, such as emus or ostriches, where the herd moves in a coordinated fashion to confuse and outmaneuver threats. The intelligence of Gallimimus also played a role in its social complexity. Endocasts of its brain case reveal that it possessed a relatively large brain compared to its body size, especially in the regions associated with coordination and sensory processing. This cognitive ability would have been essential for maintaining social bonds within the herd and for executing the complex maneuvers required to escape a predator at high speeds. Communication within the group likely involved a combination of visual displays, such as the movement of the long neck and tail, and perhaps even low-frequency vocalizations produced in the throat. This image of a sophisticated and socially integrated animal paints a much richer picture of Gallimimus than that of a simple and mindless sprinter. The world of Gallimimus was a vibrant and lethal landscape characterized by massive river systems and seasonal floods. The Nemegt Formation was a lush oasis compared to the arid deserts that occupied other parts of Mongolia at the time. Gallimimus shared this world with a diverse cast of characters, including the massive, long-necked sauropod Nemegtosaurus and the bizarre, long-clawed Deinocheirus. However, the most significant threat to a Gallimimus herd was the apex predator of the region, the tyrannosaurid Tarbosaurus bataar. Tarbosaurus was the Asian cousin of the North American Tyrannosaurus rex, and it was equally capable of delivering bone-crushing bites. In this ecological arms race, Gallimimus relied entirely on its senses and its speed. It lacked the armor of an ankylosaur or the horns of a ceratopsian, which means that any direct confrontation with a Tarbosaurus would be fatal. When a threat was detected, the herd would erupt into a chaotic and blinding display of motion. By running in different directions at high speeds, the Gallimimus could overwhelm the visual processing of a predator, making it difficult for the hunter to lock onto a single target. This strategy of evasion through velocity was so effective that it allowed the ornithomimid lineage to thrive for millions of years, proving that in the game of survival, being too fast to catch is just as effective as being too big to eat. The era of Gallimimus eventually came to an end as the Cretaceous period drew to a close, but its biological design remains one of the most successful in the history of the theropod lineage. Gallimimus represented the absolute peak of ornithomimid evolution, achieving a size and level of specialized speed that was unmatched by its predecessors. Its existence proves that the theropod family tree was capable of incredible diversification, branching out from the heavy-set predators into the sleek and bird-like forms that occupied the niche of the megafaunal sprinters. The study of Gallimimus has provided invaluable insights into the transition between dinosaurs and birds. From its hollow bones and feathered skin to its toothless beak and social behaviors, Gallimimus sits at a critical junction in evolutionary history. It reminds us that the late Cretaceous was a world of high-performance specialists where every animal was a masterpiece of adaptation. The ghost of the Namecht still speaks to us through the sandstone of the Gobi, proving that even a defenseless chicken mimic could rule its world through the sheer and breathtaking power of speed. Gallimimus remains a masterpiece of biological engineering, proving that speed and sensory intelligence were vital components of dinosaurian success. From its specialized limbs designed for the sprint to its sophisticated social structures, it stands as a testament to the incredible flexibility of the theropod lineage. It reminds us that the late Cretaceous was a world of rich sensory experiences, where the beauty of a coordinated movement was just as important as the strength of a bite. If you are ready to continue this deep dive journey into the secrets of the ancient past and want to stay updated on the latest scientific evidence, please consider subscribing to this channel. Your support allows us to continue bringing the drama and science of the prehistoric world to life with every entry. Tell us in the comments, do you think the high-speed herd tactics of a Gallimimus would have made it more successful than a solitary armored dinosaur in the dangerous river valleys of the Namecht?